So, picture this. It's your first day on the job. You've got a brand new router, still has that new router smell, you know? You're all set to build a network, but first things first, you have to tame this piece of hardware. And today, that's exactly what we're gonna do.
Right? You get it out of the box, you plug it in, the little lights start blinking, you're staring at a command prompt. And that's the big question, isn't it? Okay, now what? Where do you even begin with this thing?
Well, here's our goal for today. We're going to take these two blank slates. Let's call them Router A and Router B. And our mission is to get them talking to each other. We're going to give them names, we're going to secure them, and then we're going to build that connection that really brings this network to life.
Okay, so here's our 5-step game plan. We'll start with the basics, just giving the router an identity. Then we'll lock it down tight. After that, we connect it to the network, make sure all our hard work is saved, and finally, we'll see how it discovers what's around it. Let's do this.
First things first, before a router can do anything useful, it needs an identity. This is ground zero, where we give our device a name and a clear sense of purpose on the network.
You know, it's just like people in a crowded room. Routers need unique names, so we don't get confused. Having a device just named router is, well, it's not very helpful when you have dozens of them, right? A good name, like main office router, tells you exactly what it is and where it lives.
And here's how simple it is to do it. The hostname command, that's our digital nameplate. Boom, done. Then we've got banner MOTD, which stands for Message of the Day. This is basically your legal warning that digital authorized personnel only sign on the door. These two commands are really your first steps toward professional network management.
All right, our router has a name. That's great. Now it's time to lock the doors. Seriously, security is not an afterthought. It is one of the very first things you should do with any new device.
So think about it this way. A router has a few different doors, and every single one needs a lock. You've got the console port, that's the physical plug you connect to directly. Then you have the VTY lines for remote access over the network. And finally, you have privileged mode, which is like getting the admin keys to the whole building. We have to secure all of them.
And this screen shows you the exact commands you're going to use. See line console 0, that secures the physical port. Line VTY04 protects those 5 standard remote access lines. And the enable password commands, those protect that all-powerful privileged mode. It's really that simple. Each command locks a different door.
Now, this is super important. What's the difference between enable password and enable secret? Well, think of enable password as a basic lock. Sure, it works, but the password itself is saved in plain text, which is a huge security risk. Enable secret, on the other hand, always encrypts the password. So here's the big takeaway, the one thing to remember. Always use enable secret. It's the high security deadbolt for your router. No excuses.
Okay, our router is named and it's secure. Now it's time for the main event, connecting it to the network so it can do what it was born to do, actually move some traffic.
The interfaces are the physical ports on the router. They're its gateways to the rest of the world. But right out of the box, they're all shut down. To make them do anything, we have to give each one an IP address, and, this is the most important part, we have to flip the power switch on.
Here's how we do it. First, you jump into the interface you want to configure, something like interface serial 0/0. Then, you give it an IP address. But the real magic command is no shutdown. That's the command that brings the interface to life. It is the digital equivalent of flipping a light switch to on.
Now, if you're working with these older serial connections, there's a funny little detail you got to remember. Unlike your standard Ethernet cable, one side of this connection has to provide a timing signal, kind of like a metronome, to keep everything in sync. That's called the DCE side. The other side, the DTE, just listens for that beat. So the question is, how in the world do you know which is which?
A lot of times, you can just tell by looking at the cable itself. The DTE side usually has the male pins, and the DC side, the one that provides that clock signal, has the female sockets. And this is really important because the router on the DC end is the one you have to configure with the clock rate command.
Wow, we've done a lot of work, but here is a critical detail. Right now, none of it is permanent. If this router were to reboot, everything we've configured would be completely gone. We have to save our work. Let's just think of it like this, okay? The running config is the router's short-term memory. It's RAM. It's what's active right now. The startup config, on the other hand, is its long-term memory. It's stored in a special type of memory called NVRAM. When the router boots up, it looks at its long-term memory to figure out what to do. So our job is simple. We have to copy our work from short-term memory into long-term memory.
And this little chart shows you exactly what's going on. We've been working in RAM, the router's short-term brain. To make it permanent, we just need to follow that all-important arrow, copy running config, startup config. That one command saves everything to NVRAM, and it makes sure our configuration will be there the next time the router powers on.
Now that everything should be active and saved, how do we actually know it works? Trust, but verify, right? Here's a simple 3-step checklist. First, Show IP Interface Brief gives you a quick, clean overview. Then, Show Interfaces gives you all the details, and you're looking for those magic words, is up, line protocol is up. And finally, the ultimate test, the ping.
And there it is. That's what you want to see. Those exclamation marks. Each one is a successful reply. 5 of them? That means you have a perfect connection. That's the moment. That's when you know all your hard work paid off. And the trace command? Well, that's like a GPS, showing you the exact hop-by-hop path your data is taking to get where it's going.
All right, we've made it. Our router is configured, it's secure, it's connected, and we've verified it works. So now that it's officially part of the network, let's have a little fun and see how it goes about discovering its neighbors.
For this, we use this fantastic tool called the Cisco Discovery Protocol, or CDP. It's basically a special language that Cisco devices use to automatically announce who they are and learn about other Cisco devices that are plugged directly into them. It's kind of like the router's way of saying, hey, I'm router A, I'm a 2610 model, and by the way, you're connected to my serial 0/0 port.
And this is the awesome result. By running Show CDP Neighbors on router A, it instantly tells us, hey, I can see router B connected to my local serial 0/0 port, and it can also see switch A over on its Ethernet port. This command is just incredibly powerful for mapping out a network and troubleshooting connections without needing a shred of documentation. It's amazing.
And there you have it. We went from an unboxed device to a fully configured, secure, and connected member of the network. You've given it an identity, you've locked it down, you've built a connection, and you've even taught it how to see its neighbors. You've laid the entire foundation. So the only question left is, what are you going to build next?